Hello students, welcome back once again to the online lectures over design of precious concrete structures through JCE Connect. Okay. So in the last session we have solved one problem to calculate the shear resistance of beam with respect to the incorporating the shear developed by cable profile also. Okay, so let us solve one more problem in today's session to increase the to calculate the shear resistance of precious concrete beam. Okay, so I'll go through the problem here. So it is given a cross section of PSC beam T section, a cross section of PSC beam T section. Overall depth is 1300 mm, web thickness is 150 mm, distance of top and bottom fiber from the centroid are 545 mm and 755 mm respectively. At a particular section, the beam is subjected to ultimate moment of 2130 kilonewton meter and shear force V is equal to 237 kilonewton. Effective depth is 1100 mm. Cube strength FCK is equal to 45 Newton per mm square. Then effective pre-stress at extreme tensile face of the beam is 19.3 Newton per mm square. The effective pre-stress at the extreme tensile face of the beam is 19.3 Newton per mm square. Moment of inertia is 665 into 10 raised to 8 mm raised to 4. Area of steel is 2310 mm square. Tensile strength of the tendon is 1500 Newton per mm square. Effective stress in tendon after all losses is 890 Newton per mm square. Estimate shear resistance of the section as per Indian code. Okay, so the statement of the problem is too large here, but you have to understand one by one. Okay, so I'll just go and explain you once again. The precious concrete beam is again T section. Okay, and the overall depth of the section is given, web thickness is also given, and they are given the distance of top and bottom fiber from the centroid are 545 and 755 mm. Means they are given the location of centroidal axis. Okay, so that is from top and bottom fiber, and at a particular section the beam is subjected to movement and shear force. These two values are given, and the effective depth of beam is 1100, and cube strength FCK is given, and the effective pre-stress at extreme tensile face of the beam is 19.3 Newton per mm square. The moment of inertia is 665 into 10 raised to 8 mm raised to 4. Area of steel is given as 2310. Tensile strength of the tendon is again the FP is given as 1500 Newton per mm square, and then the effective stress in tendon, sorry, this is FPE, that is 890 Newton per mm square. Estimate the shear resistance of the section as per Indian code. Okay, so here as I told you, the total depth is 1300, width of the web is 150, the central distance from bottom fiber and top fiber 545 mm and 755 mm. Okay, so we'll start with the solution. So first of all, just we'll note down the given data, so it will be easier. So the total depth is given as 1300 mm, and the capital D is given as 1100 mm. And the width of web BW is given as 150 mm. This is regarding the cross section. Okay, then the forces, that is movement, is given as 2130 kilonewton meter, and the shear force V is 237 kilonewton. Okay. Then the area of pre-stress AP is given as area of steel or AP 2310 mm square. Then FP is given as 1500 Newton per mm square. Then FPT is given as 19.3 Newton per mm square. Okay. Then FPE after all losses, that is 890 Newton per mm square. Okay. So these are the given data. Now you have to find out, see, in the code, okay, if you go to IS, now as per IS 1343, so this is IS 1343 1980, page number 47. Okay, 47. Okay, page number 47. There are two formulas are given to calculate the shear resistance. So we have to understand first formula and second formula. When you have to use first and second formula, the second formula is given when the section is subjected to movement, both movement plus shear. The first formula is we have to find out the shear resistance, okay, where the movement is not there. So with respect to that, we have to refer the formula. Okay. So which is mentioned in IS 1343 1980. As per the given data, you refer the given data. So which given data suitable for which formula, that formula you have to adapt. Okay. So here it is given as VCR is equal to, as per this, it is given as 1 minus 0.55 FPE upon FP tau C BW D plus M naught V by M. Okay, so this is the formula mentioned in the code. So you can see here FP, FP, M naught, M. It was not mentioned in the previous problem. So here in this problem it is mentioned. So you have to refer this formula. Okay, you check out the given data and the statement of the problem. Then you have to refer the formula, either the first formula or the second with respect to that. Again, where M naught is equal to 0.8 FPT I by YB. Okay, 0.8 FPT I by YB. Okay, so it is 0.8 FPT is given as 19.3, I is 665 into 10 is to moment of inertia is also given 8 divided by YB from the bottom. YB, that is the distance of the centroid from the bottom fiber, it is given as 755. So we will get this value as, I'll just check. So we can, it is given YB and YT. Okay, so in the problem itself it is given. So YB it is given as 755, even I have shown in the sketch also, and YT is 545 mm. Okay, and even the moment of inertia is also given. Now so we'll calculate here. So 1.35 into 10 raised to 9 Newton mm. Okay, so we got the m naught. This formula is also mentioned in the code. Now to obtain, now next is you have to find out the value of tau c. See, m we know, we know, so we don't know m naught, so we have calculated. So in this formula other things are we know, it is given in the problem itself, but tau c is not given, so we have to find out tau c. To obtain tau c, refer table number 6 again from page 47. Okay. So for that we have to find out PT. So PT is given as 100 AP on PW into D. Okay, so 100 area of pressure is 2310 upon BW into D, BD, that is BW here. So 150 into 1100 depth, small depth. Okay, so that is 1.4. Here it is BD, so BD means anything but BW, because the shear, okay, it will be provided in the web part. Okay, so that's why it is BW into D, so we'll get 1.4. So now you have to refer the table. So so for that you have to interpolate between 1.25 and 1.5. so our value is 1.4. so for 1.25 the value is given as 0.74 and 1.5 is given as 0.78. so after interpolation for this we'll get the value as 0.77. so this value we got it as after interpolation, that is 0.77 Newton per mm square. Okay. So this again you have to refer from IS 1343 1980. This code is very important for precious concrete. So we got the value of tau c. So this is nothing but tau c. Now we'll go back and substitute in the formula. So VCR is equal to, we have to substitute in this formula. Okay, we have to substitute in this. VCR is equal to one minus 0.55 into FPA upon, so it is given as FPA upon FP. So FPE is 890 and FP is 1500. So you have to how to understood which one is FP and which one is FP. So it will be mentioned like the effective pre-stress in tendon, means effective pre-stress means that will be FPE. See, this is effective pre-stress, this will be effective, that's why it is FPE. After all losses, see, the pre-stress provided in the tendon is 1500 Newton per mm square, but after losses the stress reduced to 890 Newton per mm square, and that will be effective, because after loss whatever is considered, that will be effective. Okay, so after all losses, that is effective pre-stress means FPE. When it is mentioned effective, so it is FPE. and just if it is mentioned pre-stress in the tendon is, then it will be the initial, not final. So that is FP 1500 Newton per mm square. FP by FP. So FP is given as 890 and FP is 1500, bracket complete, into tau CBD. Tau C is 0.77 into BW is 150, D is 1100, and plus M naught is 1.35 into 10 raised to 9 into V by M. So V is given as 237 to make it in Newton, and M is 2130 into 10 raised to 6 to make it in kilo Newton mm. Okay, understood. So 1 minus 0.55 into FP upon FP into tau C BW D plus M naught, which we have calculated here. M naught we have calculated, M naught into V by M. Okay, so we'll get VCR is equal to, so we'll get VCR is equal to, so what VCR is equal to 240 kilonewton. So we got the design shear strength is 240 kilonewton, and here we can conclude here the actual shear acting on the beam is, that is V is equal to 237 kilonewton. The actual shear acting on the beam is 237 kilonewton, which is less than shear capacity, that is 240 kilonewton. हमारे बीम पे शेयर कितना एक्ट कर रहा है? The shear acting on the beam is 237 kilonewton, but the shear capacity of the beam is 240 kilonewton. So the shear acting on the beam is less than the shear capacity of the beam. So we can say, okay, not means we are not going to tuning the result like whether it is safe or unsafe. No, just we are going to conclude that our beam has a more shear capacity than applied shear. Okay, understood. So this is for today's session. Okay, thank you for the listening. Okay.